Hi all, welcome back to the channel. What if I tell you there is a game-changing way of connecting AI to our tools and data we use every day? Welcome to my new series of Model Context Protocol. In this series, we are kicking things off with what MCP is, why it matters, how it works, and how it is changing the way we are connecting AI with our apps. So let's dive in. So before MCP came along, connecting your LLMs to tools and data was a total mess. Let's say you have any LLM or AI agent here. Let's say you have VS Code. You want to connect it to Slack. You want to connect it to GitHub. You want to connect it to any database. You have to write all the customized integrations yourself. And let's say you switch from VS Code to IntelliJ. Then you have to write them again. So let's say you have n integrations and you are switching m times. You are working n into m times. This approach is too slow and error prone, and you have to do a lot of coding, a lot of debugging, and a lot of headache for every tool you are using. Let's take the previous example. We have VS Code here. For connecting VS Code to Slack, GitHub, and database, now we just have to call MCP server, and MCP server will take care of calling Slack, GitHub, and database for us. So if you want to connect to Slack, it will be a different MCP server. For GitHub, it will be a different MCP server. For database, it will be a different MCP server. You can either create your own customized MCP servers, or you can just pull the Docker images of already created MCP servers. So here what we did is interaction with LLM and giving knowledge to it are separated. So they are completely separate concerns in case of MCP, and you can completely plug and play different MCP servers with different capabilities. So the best part is, even if you change your ID, let's say from VS Code to Cursor to IntelliJ, or you are using a normal LLM, you can use the same MCP server, and you just have to plug your MCP server to your AI agent and it will directly work. So this separation means your AI agent will be just a brain. It will focus on being smart, and all the knowledge and context will be provided by a separate entity called MCP server, and you can just plug and play different kind of MCP servers. So this approach will give us more powerful AI applications, faster development, and a lot of less frustration. So let's talk about the architecture of MCP. We have three main core components: host, clients, and servers. So host are the LLM applications or AI agents. If you talk about clients will reside in your host application. So let's say if your host wants to connect to three different MCP servers, it will have three different clients which will have a one-to-one connection with MCP server. And the third component is MCP servers. MCP servers will give tools and resources, or we can say capabilities and data, to the LLM application via client. So as you can see here, this host has three clients: client 1, client 2, and client 3. Client 1 is connecting to files and Git server. So this server will connect to files and GitHub, and it will give the data or capabilities to client 1, and it will give to host at the end. Client 2 will connect to MCP server 2, which will connect to database and will give all the data to the host. And client 3 is connecting to some external APIs which has some context or capabilities, let's say Blender or Slack or Gmail, and it is giving back to host. So let's talk about client and server features. In this video, we will only talk about main features given by client and servers. So let's hop into the most hype feature of MCP server, which is tools. Tools you can think of as capabilities given to LLM to do something which they were not able to do before. So if you remember, ChatGPT or any LLM was not able to tell what today's weather was. They didn't have the data updated to the thing. So previously what happened, they will update the data with every model launch. So let's say my model was released day before yesterday, it will not have any knowledge of today's weather. Now what they did is they used RAG. Increase of model intelligence and increase of its knowledge are separated now. So they are updating the data daily, and as you can see on Grok, it is able to tell today's weather using RAG. You can think of tools as giving some capability to your LLM. Let's say you have a Gmail MCP server, and you want your LLM to have a capability of creating mails for you and storing them in draft. And then you will go and review those mails and you will send the mails. Now your standard LLM cannot do that. To give this capability to LLM, you can use Gmail MCP server, or you can create your own Gmail MCP server to do any customized task for you. So think of tools as capabilities which we can give to your LLMs, and it will use these capabilities if users ask for it. Let's move on to resources. Resources you can think of as get API of your REST. It will give the data or knowledge or context to your LLM if your LLM wants it. Let's move on to prompts. Prompts are usable templates that will guide your LLM how to interact with tools and resources we have given. For instance, your prompt might be like review this code and then you will paste your code snippet. Let's move to a client feature, which is sampling. So in MCP, just your server doesn't have all the features. Your client will also have features. So let's say your server wants a task to be done by LLM. So your server can request your client using sampling that do this task for me and give me back the results. Because to achieve the capability, I need this task to be done by a brain or some intelligence. I want to talk a little bit about why MCP is more dynamic than your typical client-server architectures. So let's say you have a client and a server. When you change your contract from which clients connect to the server, you have to change the client. Otherwise, the client will break. Or let's say you have to create different versions of your APIs so that the older client will keep working. But then you have to do the changes in your client and it will start working with the new version of your APIs. But in case of MCP servers, exchange of capabilities happens at the starting when client is connecting to server. Remember, client will have a one-to-one connection with server. And as we already talked about client and server features, client will tell server, these are the features I support. And the server will reply with, these are the features I support. Then whenever LLM thinks that it needs to use this capability or it needs this context or data, it will call MCP server. And if server wants something like sampling from the LLMs, it will request the client for the feature or capability. So let's say there is a little bit change on your MCP server. Let's say the contract has changed. It has to give some more data to get the request. Whenever you will connect your client to server again, it will do this exchange of capabilities and the client will know that it has to give this extra parameter or data to the server to get this task done. So you can think of creating API for hard-coded clients and creating APIs for LLMs are a little bit different. For LLMs, it is a little bit more dynamic. You can do the same to your normal API that you will not hard code and you will change the contract, but it is quite cumbersome to do and we don't generally do that. To build MCP server, we are given a lot of SDKs here in different languages. We have Python SDK, TypeScript, Java SDK, Kotlin, C#, and Swift. I personally have used the Python SDK. I have created some sample MCP servers, which I will demonstrate. And I have also used Java SDK, which I have used with Spring AI. They have integrated the core Java SDK with Spring AI to give us MCP servers. So definitely check that out. So let's move on to the fun part. This is the flow I will be showing you. So I will have my VS Code AI agent, which will connect to my Python MCP server, which will connect to my nodes in the file system, and it will provide the nodes context to my VS Code AI agent. Similar thing I will be doing with my Java MCP server also, but I will be connecting it to Cloud Desktop AI agent, and it will also get the same nodes to my Cloud Desktop. And we will be asking it questions and telling it to connect to MCP server. So it will be a lot of fun. Let's dive into the code. This is my Python MCP server. You can see that there are 4 tools I have created. One to get all the nodes, which will return file name of all the nodes. Then the second tool is if we give the file name, it will get all the content of that file. The third one is if we give a keyword, it will search in all the nodes. And the fourth one is if we give it a file name and content, it will create the nodes. So these are the 4 tools. Let's move on to this MCP JSON. This is how you will integrate your MCP server with your VS Code AI agent. There are two ways to connect. One is you can connect for the user or you can connect for the workspace. Here, as you can see, it is connected for the workspace. It is in this .vs Code folder, this MCP JSON. I will show you how to do it. You can click on this select tool. You can go down, you can do add more tools, and you can add MCP server. Then it will ask you for the command you have to run for your local MCP server if it is local. This is how I have given the command uv run my Python and my main py file name. As it is a local stdio server, this is how you can integrate. Then it will ask you for name of your MCP server. Here I have given nodes MCP server. You can give anything. After that, you can just click here and it will show you here once it is connected. As you can see, there are 4 tools it has detected: nodes, read nodes, search nodes, and create nodes. These are the same tools I have created and it has detected all of them. So let's ask our GitHub Copilot AI agent to get my nodes here. I don't have to go to the Obsidian and get my nodes. Before that, I want to show you my nodes. These are the sample nodes I have created for the demo. So you can see and we can ask it questions. As you can see, I have multiple nodes here. I have nodes of Spring Security, B6. I have some system design nodes. I have DS and Algo to-dos which I have to learn. And then I have nodes of multi-threading and multitasking. Let's go back to VS Code AI agent and ask its questions. Let's ask it to get all my nodes. Now it is asking me permission to connect to my MCP server. It already knows that for getting nodes, it has to connect to my MCP server. I will give it the permission. And let's wait. It has given list of all the file names I have in my nodes. And if you click here, you will see how it has given request to my MCP server. These are the inputs. So it is connecting to my nodes, this tool, and then it is getting the output of list of file names here. Let's ask what I have to learn in data succession algo. As you saw, I have a lot of to-dos in data succession algo and what I have to learn. Let's ask it. It is asking me to get content of this file data succession algo, and I will continue. As you can see, it has requested for file name this, and all the data of the file has come to it, and then it used its intelligence to give me all the things I have to learn here. And it is also asking me that if I need some help with the specific topics. Now I can just learn from here if I just give the topic and learn from this AI agent, and it will be so easy for me to learn if it has access to my notes. I will be keep updating my notes. It will keep updating its context, and I will be learning so fast and so efficiently. Here is my Java MCP server. I have used Spring AI here. So as you can see, I have Spring AI MCP server dependency here. We have similar tools as we had in Python SDK. The input output is also same and it will do the same functionality, but we will connect this MCP server to Cloud Desktop. I will show you how to integrate your MCP server created in Java to Cloud Desktop. You can create your Python also here. It is a similar approach to your VS Code. You have to go to the settings here, you have to go to developer, and you have to edit the configs here. Similar to Python, we will give a command of Java jar, and the jar I created in the target here. As it is similar stdio local server like Python, I have given it the command to start the MCP server when it is starting or wants to connect to it. After doing something like this, you can come back to your cloud code. You will be able to see MCP server here, as well as when you click on this, you will be able to see your MCP server here and number of tools it has recognized here. So let's ask it the same question which I asked VS Code agent. As you can see, it has given me the response. This is the request it made, this is the response it got, and it has got the list of all the file names here. Now let's ask it the same question, what I have to learn in data structures and algo. As you saw, it asked me permission to connect to my MCP server, and I allowed it once. You can see the request. It requests for the file name this, and it has given all the nodes here, and it is telling me that what I have to learn in my DS and algo. And it is also asking me whether it can create a study plan for me or dive deeper into something similar to my VS Code agent did. Let's ask it a question which is there in my system design notes. What is diff between latency and throughput? So it is asking me permission again. I will allow it, and it has got the response. As you can see, it is giving me the differences between latency and throughput based on my notes here in my system design notes. So it takes the context, uses the intelligence it has, and will give me the answer and will help me further to understand more if I need. It also can connect to internet for the extra context it needs to help me furthermore. So guys, that's a wrap on my first MCP video. We checked how MCP solves the integration issue we have, how it is so dynamic. We checked its architecture on a high level. We also checked servers and clients features on a high level. We also checked how it is more dynamic than traditional client server architectures. Plus we saw how easy it is to connect your MCP server to your AI agents or your LLMs. We use Java and Python SDK. We connected with VS Code agent and Cloud Desktop. MCP is like a superpower for AI apps. It can get a lot of capabilities and lot of information. I cannot wait to dive deeper into MCP. In future with learning, I will be releasing videos on MCP. It will be a series. If you found this helpful and like this video, so click on that like button and subscribe and hit the bell icon so you won't miss my next video on MCP. Drop a comment if you are building something cool with MCP and if you are learning MCP, and if you want to share some information to other guys who are watching this video. So happy coding and see you in the next video.